Now we can definitely start. Welcome to my presentation. Thank you for coming. Today I would like to tell you about how we managed to launch the work of analyzer without a testing. My name is Viktoriya Khanieva. I'm a C++ developer. Currently I'm working on the support of the MISRA standard. I would like to start with the most important thing, so that you would understand what it's all about. I will tell you about our testing automation experience, and what are the internal tools that we came up with while working on this and testing analyzer. Why we don't have a testing department? It's because of our specificity of our product. The analyzer is aimed at programmers. In order for a test engineer to assess the quality of the program, they need to understand and know the programming language. And if you have a small team in a small town, finding a tester who knows C++ is very difficult. You'll probably hire a C++ developer. Also, while Diagnostics is developed, it's been continuously amended. An additional part of the process as a developer would slow down the process. It's much easier to understand what the problems and amend them, solve them. I think those who have a smaller testing department would find my presentation interesting. Also, I hope among you we have here testing developers who are involved in testing, and you might find some practices that you will be interested in. Here's an example. The analyzer works with a code. There's a piece of code that has an arrow in it. This simple example. It's quite easy to spot. In the original, it was in a string format and wasn't easy to spot. Here, the third argument, which is transferred into method, coincides with the second one. Means that we have a y argument. How the analyzer finds it? It sees that we have two values, y and z. You could say that a compiler would easily find it. But analyzer is smarter. He sees that later the two variables are found, and he might think that there's a copy-paste mistake. What is a statistic analysis? It allows us to spot the errors in the program. Also, it can give recommendations on code drafting, code writing. There could be a mistake in the code style, which is pointed out by the statistical analysis, and the metrics calculation. Metrics. Example, there's a metric called cyclomatic difficulty. It shows the difficulty of the code. It shows how many changes you have in the code, and if you have a high level of difficulty, maybe you need to refactor the code, because if it works fine, it will be difficult to understand for other developers. So you can come up with other applications of statistical analysis. One could say that analyzer would not be a big problem for testing. Could look like a utility program with a relatively narrow tool spectrum. But the current analyzers can be a big product. I'll give you an example. PVS Studio, like other analyzers, analyzes not one language but a multitude of them, and in PV Studio there are 3 analyzers. The code, one is used for C++, for Sharp, and for Java. Cross-platform applications should be tested. Plugins. We already have a UIs that needs to be checked. Compilation monitoring utilities. I'll mention it later, but they are linked with C++ analyzer. Integration of various services, cloud services, and CI services. Utilities of the command line. They may seem minimalistic, but they hide big instruments, big tools. How does this automatic testing happen? The first stage is unit tests. They look special because the analyzer is based on code. The majority of our unit tests look like a piece of code. The analyzer is given a test. It checks the diagnostics, if there are findings or not. This particular in the code sees that there should be 25-31 diagnostics detections. For programmers, at each development stage, diagnostic development stage, they use special testing, intermediary testing. They can also launch them for all unit tests to check, to make sure that his amendments in the code would not break anything in other parts of the code. As of today, we have over 1,770 tests which are launched in all the 3 platforms. Is that easy? Is it enough for a programmer to sit down and write unit tests for diagnostics? Would that guarantee that diagnostic would be precise enough? Here's a simple example for you of a unit test for diagnostics which detects division by 0. For example, 3 minus 3 equals 0 divided by 0. What if it looks like this? Would a programmer be able to consider this? If a programmer had to come up with all the options for diagnostics, it would be a load that they would not bear. But the diagnostic process is final. Even though the minimizing of false detections is linked with the code, it is still final. How do we achieve it during the development? We created a self-tester internal tool. What is it needed for? It checks our diagnostics. It's an example of C++ tester, and there we use over 140 projects. The local pool is majority of them are real open source projects with working code. Some of them are synthetic tests for testing certain special functionality of the analyzer or special diagnostics that really have mistakes in them in real project. Now it takes 2 hours to fill all these tests. A few words about the algorithm. We have additional work in the kernel. We analyzed the testing project and received a log. It's a log of all the mistakes the program has come across. We have a reference log which we received before the amendments were made. We compare them and create a report, change report. In HTML it looks the following way. Based on the differences, the programmer can say if his diagnostics works fine, whether it has broken anything and whether it detects errors. They can also assess the program using the time frame. It shows the time frame, the time needed to program to finish, to run. It's available in a user-friendly UI, particularly in a plugin. Messages are different and they show changes in the messages. For example, a message could have disappeared, could have been added, the level of warning could have changed, and others. We're going back to this round-shaped diagram. Thanks to the self-tester, the false detections are becoming lower and helps us to avoid repetition losses. Analyzer is a very valuable instrument. Jenkins. We could have dealt without it. We have implemented a big number of testing scenarios using Jenkins, starting from the build and build checks until the run of the testers and self-testers. It is regularly repeated not only by the programmer. A few examples. What are the tests that we have? For example, builds with various compilers. It allows to check that not a single compiler adds some mistakes or errors to the code, because the messages that compilers provide are different, and they are different for various compiler versions. Dynamic analysis. Dynamic analysis allows to check the code for leaks or for strange behavior. As you can see on this screenshot, the coverage of the code by dynamic analysis is about 90%, which is a good figure. Then statistical analysis. We're sometimes being asked if we check the PVS Studio using PVS Studio. In fact, we do. We also use client tidy for this. This test also run on Jenkins. But we have developed a small toolkit for this, which allows to make the work with the results of statistical analysis more comfortable. BlameNotifier is a small utility program that examines the results of the program run, and if something is triggered in the analyzer, a programmer receives a letter. The next morning, after the night run, programmer doesn't have to remember that they need to check something on Jenkins. In his mail, he sees that there are some errors. Next comes the CL monitoring. For C++, there's a huge number of options on how to compile a project. A huge number of compilers are available. Building in and forcing a developer to come out with this desired solution for building in every time is difficult. The program launches a monitoring, launches a compiling, the analyzer works. Naturally, this needs to be checked, because the compiler is a non-trivial process, which is fraught with errors. The same logic of comparing with the reference log, we compare the results of a compilation, and we see that the utility of the compilation monitor works properly. Then come the UI test. The necessity for UI test is based on the fact that we have a plugin which has an interface. Many years ago, when it turned out that they need to be tested, we didn't go far, but we selected the Visual Studio toolkit. Why? Because it's easy to use, and you can simply run the scenarios it needs and the test will be ready. How does it work? It drafts a map of the control elements. Based on this, it runs a test. We had a small problem, small issue, because the system had been used many years with maps added to it, and the control map grew so big because it was regularly amended with additional duplicates. The test became unstable. We decided to use the work of developer to solve this problem. Eventually, the control map went down by 30%. The test became stable. Another example of the issue, we have a case when after the analysis is launched, the analysis window is in a special place. It can lose its background also after the analysis ends. It can stay over. So looking at it was not comfortable, not convenient. Something could go wrong. We decided to work with something more stable. We decided to work with the properties of the menus. While analysis is ongoing, this menu property item is inactive. When it becomes active, the analysis is finished. An universal function was coded to be reused for every similar situation. Who writes tests and documentation? Sometimes it could be a pain. Of course, it depends on the tools that you're using for it. But anyway, if your documentation is later transferred to the website, the format can break down. Since we have documents in Russian and English, and documentation is also used by the translators, we decided to use the Word format. The publisher allows to, without extra effort on text formatting, to make a document look fine. Eventually, we started writing a lot of articles published on Harbor and other resources. The publisher grew even bigger with time. Now it allows us to format articles in a convenient way. They add missed errors that we found in the error database that we have on our website, and many others. An example of why it's needed. In order for everything to look fine on the website, the Word needs to have a special headlines and different fonts. When a person joins the company, they can have a problem with it. Word can be unpredictable, with styles becoming unruly. The publisher allows to format without any pain. How does it work? It's no secret for anyone that the Word file is an archive with XML. We passed this XML file and created Diagnostics tool. Currently we have a big number of diagnostics, tests for own names, mistakes for incorrectly added pictures, which is a big pain in itself. Here you can the problem with the images that have alpha channels. So when it's posted on a website, instead of the original white, you get something else. Support of the analyzer. Naturally, not a single testing system can guarantee that the product eventually will be error-free. For the analyzer working with such languages as C++, Java, which are actively developing, it's natural that needs to be continuously amended.
And after the release, we are doing some fine-tuning for the users, and it sounds like a good system. We simply move the testing to our users, but it's not exactly like that, because of the simple reason that program developers can invent amazing things that nobody could even think of. Like, for instance, here you see a picture with some letters there. No, there was a case when our analyzer was on the hang and we didn't know what it was, and it turned out that the user had 26 gigabyte literal. That was a borderline case. Who could take it in consideration? We couldn't. And more detail about this C++ can be seen in Yuri Minaev's presentation. He's my colleague. There are some interesting cases peppered there. You might find something unusual there as well. And naturally some fine-tuning related to the core behavior. As I told you, in the actively developing language, we need to improve the language. We add new features into the language, new language standards. So this is an unending process. So, due to some unknown reason, I wrapped up so fast. See, I was jumping ahead of myself. But anyway, in conclusion, I'd like to say that we shouldn't be afraid of automation, because there are many articles now published that automation is for the worse. But automation can be different, and in real life, when your project is developing for a number of years, it becomes quite visible which things can be automated. Also, it makes sense in the course of development. We need to look for repeated stages, not only in the course of development like it was with the documentation. Often these things are omitted when people write documentation and do that as they usually do. It's a monotonous thing, like something they have to do. But if you think about it, you can really automate it, considering that the product is developing for many years. By spending some time for the development of additional tools in the beginning, you can save a lot of time in future. And the last thing is that the small team without a testing department, a small testing department, can develop a full-fledged testing system anyway. A full-fledged testing system which will be capable of protecting you from reputation risks and simplify the development process. That would be the end of my presentation. It was quite brief. Hopefully you have many questions for me. Thank you very much for your presentation. We also do like this. We put together all different options. First question. 21 million lines that you put together, would that be enough for you? You expand it only because of the feedback, or you have some other expansion process? In the self-tester, you can add new projects there. Periodically we do this. We add synthetic tests when something specific appears, because real new projects, new language standards end up there, and the self-tester, I used C++ as an example. Also for Java there is this self-tester for Sharpie. There is also self-test, and they're expanding. No, my question was whether it was enough. You said the new standard don't end up there automatically. You have a new feature you want to test against the new standard. You say, okay, we have 21 million lines of code. Does it cover the new standard or not? With the new standard, there's yet another thing, that it doesn't enter the project quickly enough. We still have some time. So, how to release a product when there is no source of products with the new standard, and your feature is a new standard. Our program developers, just like others, have to sort through the new standard, and at the initial stage, mostly it's done at the unit tests. So in other words, you release a product, test it by unit tests, and then when open source project is added, you add it. It's done gradually. There are a lot of diagnostics, different options, and they're added with time. We cannot maintain all the new features of the new standard. I understand, okay. And the second question, such a number of checkups usually gives birth to many failures or fails in tests. Who is sorting through all these failures? In fact, for self-tester, there's a very convenient release format or output format. We see the differences, and also when developing single diagnostics, there are not so many warnings, not so many differences. With the new ones, and usually there are not so many warnings, and the program developers are looking at them locally, and they can also make some changes. So the problems are not numerous, and it is the program developers who are sorting through this. Yes, it's easier for them to do that, but then you can do it without testers in the first place. Hello, my name is Marina. Thank you very much for your presentation. And can we go back 2 slides about the errors in lateral? Any tester can tell you that the first testing is against the border value, so nobody could foresee it, as you said. But the question, maybe you still need testers, and who is testing your instrument? Well, in fact, this is a very borderline case, but you still test the border values. Yes, we do test for big laterals, we check for big masses, but lateral is not the full lateral. This is just a small fragment, 26 megabytes of text. But could it have been foreseen? Maybe, but then your product needs to be tested. Just like any testing system, it is developing with time. Tests are augmented, and here we had some deficiency, but for many years it was enough for us to have a borderline case for big lateral. And in terms of program development, it does make sense, but it's quite a standard test or check up what you have shown. And it turns out that who is testing your instruments then? You don't have testers. No, we don't have testers. Then who is testing your instrument? Users. Not only users, no. As I said, we use PVS Studio, and at each stage the developers themselves use PVS Studio. And there was a borderline case which was taken under advisement. That wasn't that big, but you understand, to assess the whole system you need to go beyond the system to check PVS Studio. But with PVS Studio is not really reliable. And I have a question coming from this one. It turns out that some of the checkups are done by the users. Again, whose time is more valuable for you, the time of the developer or the time of the user? The thing is that it's not that users do not send too many complaints? Well, because many Jenkins is something that many people already using. In Jenkins we have many standards and customized tools. We try to test and run everything that we can through it. For instance, the assembly is done not only in PVS Studio. We use certain monitoring. Our self-tester is not only run, it is self-assembled also. We look for errors there as well, so we try to enhance our coverage. But as I told you, we have a small team in a small town, and in that town to find a tester with a C++ knowledge is impossible. And outsource, well, to find a tester at C++ at such a level that they would be able to assess the quality of an analyzer, it's better to integrate them with a developer. Thank you for your question. Hello, my name is Dmitry. Thank you very much for your presentation. Question for UI tests codes. You mentioned that they're obsolete and the whole technology and the 19 studios, they don't have used them at all. Do you have plans to move them to another platform? At the moment, everything works fine, and we're using it because it was our historical decision. But we are not sorry for making such a decision. These tests work fine. They found errors, but perhaps in future we need to revise it. But are you going to revise it? I can't tell you for sure. So far it works. Thank you. Oh, thank you very much. I have the following question. The publisher, why there was a need to structure the document so much? Because it's not really normal thing to automatic testing and documents generating. The thing is that the documents are written by the program developers. They wrote diagnosis and documents. Documentation is when the analyzer is running. The ones who are using it, they can move to the documentation, and documentation contains explanation of the error, the small guide how to correct it and where it came from. Of course, it would be much easier to write for the developer to write it. Also, we have translators. Like the situation is one, why should we waste the time of the program developer to verify the styles, because word can sometimes be unstable, and for the website publications we have quite a serious approach here. Okay, I understand. Thank you for your presentation. My name is Roman. I have a question for UI tests. I guess the scenarios are written by developers as well. Well, you don't need to write them in most of the cases. The work with the code started when they were corrected, and for some time it was the developer doing that. Generally speaking, there's one single person responsible for that, who knows how it works, who can start a new scenario. We have selected this scenario because it's easy to create tests there. It doesn't take too much time. And do you check the coverage with this UI tests? We have a specificity. Plugin doesn't have so much of user interface. There's a menu, a couple of windows, and the menu bar at the bottom. This system was developing for quite some time, and generally speaking, the scenario covers virtually all the options of PVS Studio. I think all of them. And another question, do you use phasing testing? This is a case when the case that you showed, it could have been of use. Maybe you can tell me later about this, and we'll try to apply it. And the last question, do you plan to open source anything out of this? You mean to publish the part of the code? As far as I know, no. We don't have plans like that. No instruments, nothing, right? In terms of the auxiliary instruments. Other interest? Well, the trust to the product. It would be great to see what people are doing by looking at the source. Maybe someday in future. Okay, thank you very much. Thank you. It was a great presentation. You looked at it from a different angle at our work. My question is more philosophical. Aside from the developers, do you have anybody else in the team, or you're a jack of all trades? Well, we have managers, we have translators, developers also sharing, dividing into teams. It doesn't work like somebody can be randomly approached and told to write a UI test. No, it doesn't work like that. Mostly each one has a role to play, but we have a small team, and we have an internal hierarchy, if you will. Thank you. And another question. Why don't you hire, outsource a tester with C++, because it would be easier for them to become the developer? It's interesting. Yes, indeed, because the result of the work of the analyzer, most of the warnings are related to quite serious structures, some newer standards, and for that a person needs to know the language very well, and only then can we have the high quality processing of the result. And your developers, aside from the knowledge of the development, do they have any idea about the testing? Have they read anything to test what they're developing? Generally speaking, yes. We have long-term products, 5 systems, and they didn't appear in the beginning when we had to test it and let's create the automation system. No, it happened gradually. They read articles, they apply new approaches, which seems useful to them. Okay, you're great. Thank you. I wish all success to your team. It looks like that's it, right? Thank you for your presentation. Very courageous presentation to speak to the testers and say that we don't need you. I understand you that your product is more targeting the program developers. It's used by program developers, and it does make sense to use them. So I support your theory. But simple question: how often do you issue releases, and how many incidents or bugs do you have per release in response? Our releases are all in a calendar, and they are done periodically. Within a month we have the development, but the bugs are quite spread out. We receive them from older versions. They can go through diagnostics for quite a while, and then some program developers can invent a case which breaks down the diagnostics, but it mostly relates to some twisted, complicated constructs. But interface errors, such things, they're more often, almost always, localized, because the developers are working with the freshest possible unreleased version of Analyzer. And naturally, every day they go through all the buttons because they work with the Analyzer. And in other words, they work with all these scenarios. So basically, your program developers are also like users, and you get feedback from them right away. Yes. It's quite a natural process. Okay. Thank you. Thank you. Okay, don't forget to assess the work of the speaker by a smiley face when you exit this room.